Now the next result is, so if f of x is a constant function, so let f of x equal to c for all x belongs to R, then in that case the set of all x such that f of x greater than alpha will be measurable. ഇനി നമുക്ക് prove ചെയ്യേണ്ടതാണ്. So we are going to show that set of all x such that f of x greater than alpha, this is measurable. Now f of x equal to c ആണ്. ഇനി നമ്മൾ ആൽഫ എടുക്കുമ്പോൾ alpha can be greater than c or alpha can be less than c. ഇനി f of x will be equal to c for all x belongs to R, constant ആയതുകൊണ്ട്. Now when you take the case when alpha is greater than or equal to c, so f of x in the value c ആയിരിക്കും എല്ലാ x വാല്യൂവിനും. So when alpha is greater than or equal to c, this means that is a set of all x values such that f of x is strictly greater than c. അപ്പോൾ അങ്ങനെ x values ഒന്നും ഉണ്ടാവില്ല, കാരണം എല്ലാ x valuesനും f ന്റെ value c ആയതുകൊണ്ട് you cannot find x values such that f of x is greater than alpha where alpha is greater than or equal to c. So when alpha is greater than or equal to c, this set will be equal to the empty set, and we know that the empty set is measurable. So when alpha is greater than or equal to c, the set of all x such that f of x greater than alpha, that will be equal to 5. So in that case it will be measurable. In the alpha less than c ആണെങ്കിൽ ഇനി നമ്മൾ set of all x such that f of x greater than alpha എടുക്കുമ്പോൾ അതിനകത്ത് so you will have f of x equal to c വരുന്ന കേസും കൂടി വരും അതിൻ്റെ അകത്ത്. greater than alpha strictly less than c ആവുമ്പോൾ so this set will be the entire set of real numbers. So the function will be defined for all x values in that case, and the function value will be equal to c. So therefore when alpha is less than c, the set of all x such that f of x greater than alpha, that will be equal to set of all x such that f of x equal to c. So that will be the domain of your function f, which is R. Now as we know R is measurable, so therefore in both cases alpha ഏത് value ആണെങ്കിലും set of all x such that f of x greater than alpha is always measurable. So we can conclude that f is measurable and f is a constant function here. So every constant function is measurable. ഇനി നമ്മൾ രണ്ട് പ്രോപ്പർട്ടീസ് കണ്ടു. ഒന്ന് f raised to n, അതായത് f മെഷറബിൾ ആണെങ്കിൽ f ന്റെ ഏത് പവേഴ്സ് എടുത്താലും അത് മെഷറബിൾ ആയിരിക്കും. അതുപോലെ when you take linear combination of two measurable function, that is again measurable. So combining both the results, so when you take a polynomial in terms of f, so if I am taking a function of the form a n f raised to n plus a n minus 1 f raised to n minus 1 plus etc. a naught, this is a polynomial function in f. So f in the powers and the linear combination ആണ് വരുന്നത്. So by the previous notes, this is again measurable. Raised to n in general measurable ആയിരിക്കും, linear combination measurable ആയിരിക്കും. So therefore a function of this type or a polynomial of this type in f is measurable. Okay. So using all these results, now we can conclude that M is an additive abelian group. So M is the set of all measurable functions defined under the operation plus, so let M be the set of all real valued measurable functions which is defined on a measurable set E. So if f and g are measurable, so we have seen f plus g is measurable, so f plus g belongs to M. അതുപോലെ അസോസിയേറ്റീവ് ആയിരിക്കും, f plus g plus h will be equal to f plus g plus h, and it contains a zero element, so 0 belongs to M and f plus 0 will be equal to 0 എന്ന് പറയുന്നത് നമ്മുടെ കോൺസ്റ്റന്റ് ഫംഗ്ഷൻ വരും. കോൺസ്റ്റന്റ് ഫംഗ്ഷൻ നമ്മൾ കണ്ടു മെഷറബിൾ ആണ്. So f plus 0 will be equal to f, that will be equal to 0 plus f. So 0 is the additive identity, and again f measurable ആണെങ്കിൽ minus f measurable ആയിരിക്കും. So that is the additive inverse, and അതുപോലെ commutative ആയിരിക്കും. So f plus g will be same as g plus h. So therefore we can conclude that m is an additive abelian group. So if m is the set of all real valued measurable functions defined on a set E, on a measurable set E, then m is an additive abelian group.